Hey all, thank you for the opportunity. I'm really happy to give some insights. It's more practical, this talk. And I mean, after Pepe showed like what is possible if we do this job right, I'm like talking about what is needed to do that actually, what he was showing. I call it the two sides of the data, not because like they are exclusive, like you can do the one but not the other, but they are like kind of independent, and there's much focus on the one side, but I want to raise attention to the other side. And my main message on that is that combining IT and science is a hard task, and to get them in line and to work efficiently together. And I will give some examples on that, on my experience, like implementing and applying Nomad towards a lab, like you saw it on the last slide of paper, like to our high-sprint lab. And I'm also the one in contact with the people from KIT, where we also experimenting on that right now. Okay, what I mean with the two sides I'm talking about, the one is the data standard part. This is about understanding, like getting to a community agreement of what is needed, what is like important to cause something fair, like across a given domain. And the other part is that what I will call user customization. And this is, I probably don't have the right language already like to address this perfectly, but it is concerned about what makes a tool, workflows interesting enough that they are not only be done because you are told to do them, but they are done because they help you as a scientist, as an individual scientist in your lab. And this is something I'm experiencing a lot, because like what is the reality in the lab is much different from what group leaders and PIs are discussing in meetings on data standards. And to raise awareness to these needs concretely in the lab is basically a big part of my job. Okay, first, some short notices on domain standards. I mean, I listed here some projects where I am involved in that. There are many more, I know. For example, the backbone to what I'm showing you here is the autoparasol metadata project we're having in the Helmholtz Association. This is why KIT, people from Erlangen and we from HZB are collaborating, like the last slide paper showed. So there's like a Helmholtz internal project. There are other projects in the perovskite area, which are grouping together people not only from Germany, but also internationally, at least for Europe, and where we're trying to build the consensus on how solar cell manufacturing data should be recorded fairly. I want to start, like my first example I'm telling you is just to highlight maybe a bit of an understanding regarding how material data should be stored. If you come from the perspective you have one material, and this material has certain properties and measurements, and I want to look at this data of this material solely only, then you might run into practical problems if you're actually considering what happens in the lab. And for that, I want to give like this quick example, which is regarding data modeling. It's a classical lesson from data modeling, which is known to people who work with relational databases and all of that. But it's probably important to understand that also to the material science community to see like what is needed from a data modeling perspective. In solar cell, and I always try to keep it concrete, like referencing solar cell manufacturing, but this can apply to different areas of research, obviously. So in solar cell manufacturing, usually you have something called batches. So people sit there, they think about like what they want to do, and then they create like a couple of samples, and then 80%, this is like, don't call me on that number, but like most of the processes involved are actually the same or more or less standard. But you never know like which of them are the standard ones and which are you like now interested in like doing new stuff with. And for this means, I think I can turn this maybe a bit easier. So solar cells see a variety of processes, and like a lot of these solar cells see exactly the same processes, such, for example, as cleaning or deposition processes or whatever you fancy you're doing. So you don't have only samples seeing a lot of processes, but you also have processes seeing a lot of samples. And this means that like in a comprehensive archive, material archive, you not only have entries regarding materials, you also have entries regarding processes. At least in the lab state, I can see that in a publishing process, you flatten out these relations and you copy a lot of data, which is then like immutable after that. But in the lab processes, you need to have the flexibility to combine all aspects which you're doing in the lab arbitrarily with each other without creating redundancy. This flexibility is something like I was realizing I'm in a lucky position that I'm in 2 cooperation projects where we have archives at work. Like I'm in a collaboration work with the FHI, where there's already an archive in use for probably 20 years. I'm not sure, but like for a long time. And I see how people engage with such a system. And I'm in the lucky state that for our silicon solar cell part at PVComB, we have an at HZB called PVComB. We have like long-term experience implementing like data schemes. This is not necessarily can call themselves fair data, but like as a tool to be used by scientists over a decade collecting data, it is really helpful. And this made me realize that like this flexibility, like what you want to do in the lab needs to be arbitrary. You don't know like how many layers you want to produce, how many different aspects you need for your for the devices you're producing. And this kind of flexibilities needs in the lab process this kind of end-to-end, we would call it in the relational database, end-to-end relations between processes and samples. And I think originally in Nomad, you had like this really strong material focus, like you have one material and all the properties of that. But this is, at least to the lab process, a bit unhandy. Okay, let's go to the second part, to the second side, which is like how to record the data. Like people just illustrated like what you can do once you did that properly. Like if you have like hundreds of authors who scan 16,000 papers or something like that by hand, great, you have a big data set, but like what is like a good process to get this data, not like with afterwards, after publication, but in the forehand, it even get more data than that, like the measurement data and the characterization data and the process parameters and everything like that. So if you're in the lucky situation that you have digital traces, it's kind of easy, and you can try to think of automating and processing this digital traces like files, which come somewhere, or like AP calls to an instrument or whatever you fancy. The more difficult part in the solar cell manufacturing is one of that, is that a lot of steps still involve a lot of manual activity by scientists in the lab, like having hands in a glove box. And having hands in the glove box is already the first point. Like if you have your hands in the glove box, you don't have your hands on a computer, and you cannot do certain things. So you need to find a way how to get this information in the computer. And if it's only referencing certain parts, like at least some parts of most steps is like a comprehensive history of like what a sample has seen and what has happened to it, you need to have at least some kind of references, because the instruments usually don't know what they are measuring if you don't tell them. Also for that, I present like two examples. Like the first example is that, first of all, is regarding efficient documentation. So you have usually like 10 or more different processes to produce a solar cell, like from cleaning to deposition of information to all the steps involved. And a lot of, and like what is actually important for a specific batch, like of 20 samples or something like that, is usually only recorded in an Excel sheet. But in these Excel sheets, people record like what is different to the standard process, because the standard process everyone knows. Like no one knows like who's outside of it, but like everyone knows what the standard process is, or like which kind of standard processes you use. To be efficient, you only record the things which are different for your specific series of experiments you want to perform. But this information then is like helpful for people who are like insiders, but like you cannot use this for outside people. So to have efficient documentation, you need to think of ways like how to point to what is standard and what is not standard. And being as efficient as an Excel table to a specific scientist in the lab is a hard task. It's not easy to, like, if you tell some software tool to use, you probably at first need the scientist to take a lot more time, and it's difficult to be as efficient. Obviously, you get better data out of it, but like, will people use it if they have like an hour or 2 hours per week more on overhead? What is recorded depends on what is useful to the scientists, and anything else which is useful to people outside of the scientific process needs to be thought about how to record it. Otherwise, it gets lost, at least to a certain degree. So I'm trying to talk to our scientists at HCB and figuring out what do they need to have a at least close to efficient way of documenting an interaction with a digital system to an Excel sheet and getting their data recorded and what I can ask from them to get integrated. And I really want to point out at this how important this is. The third thing is like I want to highlight again the goal of why, for example, our scientists are producing solar cells. So there's like a clear sequence of workflow. Paper already like illustrated it a bit, but like I'm also highlighting it a bit more. Like in the manufacturing circle, you have planning. So you need assistance in planning. What kind of processes am I using? What kind of parameters I'm using? How do I set up all of this? And how do I enter this into a digital system, which then makes use of this? Then you go on the lab where you only have pen and paper, produce the things, you come back, and if you notice something which you want to record, you need to be able to record this deviations of your original plan in the digital system. After that, you do performance measurements and characterizations. Those steps of manufacturing, they are, at least in some labs, or at least to a certain degree, manual and don't leave digital traces. In the measurement cases, you usually have digital traces, so life is a bit easier on that point. And then in the end, you want to create groups. Like it's not about machine learning. Like obviously you can do machine learning at a certain point if you have enough data, but like first needs are like create the typical plots you do when you do publications with a certain batch over the data you got. And you want to group certain parameters like of the processes, of the composition, of the ratios of any solutions or whatever you use in your processes, and group them by performance results you get out of your measurements and your characterizations in the end. And so you need effective querying of your data you created to then write the individual plots you need in the end, which you can then put in your publication. If this is done right in a digital system, it is worth taking a bit more time in the being more effective than an Excel sheet part. So if this is done right and you can show users how they can do that, streamline this kind of process digitally with a good digital system, this can be a key selling point. So I'm a data steward. I'm not sure if anyone knows what that means. I still don't. I'm trying to figure that out while doing my work. But for me, my scientists are more or less my main priority, so that their life gets easier, so that they can do what they want to do better. And this is my first priority. And I say it here, like fair data is really nice. I know I come from a data scientific background. I know like how nice it is to have fair data. But for me, it's only a byproduct of all of this. It's a really important byproduct. I'm not saying like it's not important, but it's like only if I have workflows to get this data into these systems, I can talk about making this data fair. And this is a hard task. At least it feels for me so far. So we need these convenient tools. And for me, Nomad is one of these tools. And I'm having high hopes, and I'm really interacting. I've gone from writing mails to Marcus to going to material science, writing issues, to being now more or less like right to the core, writing issues in GitHub, and getting really close to what is probably other people are not much closer to like the core development than I am after that time. And what I really like is like that these two sides can be separated in Nomad quite nicely. So on the one hand, we have our standardization projects, like I said, autoparasol in the beginning, which is for solar cells, or other standardization processes, where we actually develop an ontology. And in principle, we can take an ontology in OL and just map that back to Python classes. Obviously, you don't want to have all of the quantity, like all of the, you don't want to have temperature as a class. It can be an attribute, it's okay, but like in principle, this is possible. And this can happen on the left side without me talking to lab scientists. I can do this with all of the PIs on the PI level, talking about like what is spin coating, what is dispensing, and all of these kind of stuff. And I can rewire in the background and set relate. These arrows indicate relations. These dots represent entities like processes, like spin coating or samples or batches or whatever I'm cleansing. And I can rewire that as much as I want in the back without like talking to any lab scientist. This is the left part. And on the right part, I'm always talking about a process in a lab, in a room where someone puts his hands in. And these things need highly to be as the user needs it. And the user means the scientist who's actually producing the samples. So by having a logical infrastructure where I can separate these things, I can be efficiently in my work as a data student. And the data student in the standard development supporting this kind of work, having a proficient understanding of what is happening. And on the other hand, talking to PhD students and showing them what is useful to them. And this is what I really like doing, because it's really fun to go there and say like, okay, what do you want? And I just give it to them, and I make sure that due to this hierarchical relation, all of the nice things in the back are taken care of. And Nomad can do that. This is really powerful. Okay, I'm also here as an external one, and I'm often in issues, so I also come with a bit of a list of things to be a bit more aware of in developing this tool, because I think I'm not here to criticize or something, but like it's an ongoing process, and these are maybe 2 or 3 things to raise a bit of more focus on. One thing, and a lot of projects have data management compliance in their project scopes, but using this kind of project resources to have a sustainable tool is a big challenge. Obviously, you can set up something which is compliant to the project goals right now, but if they are looking tighter, you easily can see that a lot of those might not be as sustainable as they claim to, because they involve a lot of manual work. So you always need to have in mind that you only need to enter information once at most. Like if it's automatically generated, you don't need to enter it at all. But if not, like you need to check like, I only want my user to do that once. And what that actually means is completely different to different lab sites. But like you need to have a framework offering flexibility in offering that. I don't know what that concretely means for general scope, but it's a really important thing, design principle have in mind to be efficient to users. The second is like, if you have all of this is like a concrete aspect of Nomad right now, and as it's set up, is like, if you want to generate these plots I was talking about, like grouping different things together, you need to be able to query this data efficiently, which is something I know it's worked on, it's thought about, but it is important to, if I look at a bunch of samples like solar cells, 10, and I want to filter and group them by a certain process property, they have all seen the same process, but with different values in a temperature or in a pressure or in a gas of an atmosphere or whatever. I need to be able to get this data, query this data efficiently from the data set, which is not easy, I know, because it is tackling the heart of certain principles, but like, this is also a bit to consider. And the last point is UX design. I know it's really hard. UX design is a difficult task and it's always overlooked because people are like, functionality is everything and design, I don't care. But it's important. If you look at things intuitively, we all use computers with like websites with well-designed thoughts. We are used to looking at certain parts, and also our scientists are used to using these tools. Everyone who uses any web page at all is used to these kind of principles, and you need to make sure that this is also being taken care of. And it's difficult because these people are even more difficult to find probably than software engineers, because it's like such a demand on that, because the success of things like design is so much. Like if I show you an Excel table, which is like cluttery, or if I show you like a fancy, well-designed web application, I can show you the same things, and the reaction is like from here to here. Okay, then my conclusion is, Nomad can separate data standard development and customization quite nicely already, and I really like that. And this really gives me the possibility to do data processing in the, we call it base class, in the backend, do certain things already. And on the other side, like tackle the needs of the individual scientists in the lab. Lab work probably will include manual steps over time, so we cannot expect to automate everything. At certain points, we need to think about how to record this data. Sustainable data management, if it's not like just a checkpoint in the project scope, needs to be efficient for the user, and you need to have the user's perspective. Not only do like nice standards and link data, you always need to talk to scientists who actually do the work and value their position, because it's always harder to impose it on them. Obviously, it's easier with fresh PhD students, but like if you grew accustomed to certain workflows, you need to be convincing to ask people to change their beloved workflows. And we need to think of long user stories, like what is like from the beginning to the end something you can offer with a digital tool, with a data management tool, so that you have a complete user story. Like not only say like, yeah, this is the part where I enter my data, this is the part where I query my data. No, say from the beginning, from the planning to the plot and the publication, like what is needed for that? And how can we offer that streamlined over the whole process? Okay, I hope I didn't talk too long. That was my talk for today. Thank you.